The role of dark matter in galactic evolution. Dark matter is one of the most mysterious forces in the universe, and it plays a crucial role in the evolution of galaxies like the Milky Way. Although we can't see or directly detect dark matter, we know it's there because of its gravitational effects on stars, gas, and other visible matter. Dark matter acts as the glue that holds galaxies together, forming a vast halo around the Milky Way that influences its shape and behavior. Over time, the distribution of dark matter within the Milky Way will change, driven by gravitational interactions and the movement of matter within the galaxy. This could lead to shifts in the galaxy's structure, influencing the shape of its spiral arms and the density of its core. Dark matter may also play a role in the Milky Way's eventual collision with Andromeda, determining how the two galaxies merge and what the resulting structure will look like. Dark matter doesn't just affect the galaxy's structure, it also impacts its ability to form stars. By creating regions of higher gravitational pull, dark matter helps gather gas and dust into dense clouds where new stars are born. As the galaxy evolves and its gas reserves dwindle, the interplay between dark matter and visible matter will determine whether star formation can continue, or if the galaxy will enter a quieter phase. Understanding dark matter is one of the greatest challenges in modern astrophysics. As we study its role in the Milky Way, we're not only uncovering the secrets of our galaxy's future, but also piecing together the larger puzzle of the universe itself. Dark matter might be invisible, but its impact is written across the cosmos in every star, planet, and galaxy we see.